We're on chapter 2 of the book, and the title of this chapter is The Power of Functions. Um, so here we go. So here's an example of some Java code that apparently got him stuck. Okay, so here's a um, public static function that returns a string um, that says, give me a string and something to append if it's small, I guess. So if the length is less than 10 of s, append the whatever, otherwise return s. Okay, append if odd length. Yep. Okay. Mm-hmm. This, wait, what? Oh, it's not small. Okay, I get it. Sorry. What do I put here? That's a good question. You need a predicate. Yep, there's a predicate. Mm-hmm. Is small is odd length. Great. Passing functions as parameters. Okay, functions as parameters. Functions are first class citizens, or functions are first class is typically how people say that. Code is data, data is code. I've not seen this saying, but that sounds about right when thinking about Lisp. Excuse me. Okay, while this is powerful, it's terribly dangerous, and in very rare cases, for example, genetic algorithm. I guess I don't understand why that is, but okay. It's the idea that functions are different from integers, where the real power is. In our earlier append example, okay, so here is our function predicate, or just, well, it's just a predicate, but man, that's a lot of words. I guess this means you can only have a unary function. I don't know. Or maybe you have to write it like function of function in here. I don't even know if you can. I can't even highlight that for some reason. Oh, there we go. I don't know if you can like embed a function in here. Again, I'm not a Java person. Okay. Oh, they're just showing like the alternative syntax or something. Wait, I don't understand this. We have this is small here, and then also is small here. Are these not the same things? Again, we're talking about Java, so not that big of a deal, but it's kind of weird to me that those are both defined there. Maybe this won't actually compile. Okay. Cool. Cool. All right. So Peerscript code. Nice. Let's write some Peerscript code for the funds. So oh, wait. Actually, I think we can just write can you do sections in here? Apparently not. Oh, well, that wouldn't work anyway. Hang on. So we actually want to do this. But I think it doesn't even like the yeah, okay. That's fine. Again, I'm trying to write Haskell in Peerscript and I just don't know how to do oh, also that's not even the right way to do oops. Data string code points. Do I not have oh, I guess not. Is that really where that goes? Oh, hang on. Gotta get this going. Oh boy. So I think I just do what did I set this to? There we go. Okay. So per suit length. Data foldable. Well, that's the array version. That's the list version. Data string code points. Interesting. I have not seen that before. Okay, I need to fix this as well. I forgot to pin my stream stuff. Okay, that should be good now. So import data string code points. Build or sort. Okay, so we need to include this thing, which comes from Peerscript strings. So we can get this, I think. And in the dependencies, we can add strings, I think. And then we can build. Okay. Oh, we're not in Nix. Oops. Hello? So, yeah, anyway. I think that will fix the issue. It's still not happy. Okay, should be happy now. Cool. So now we have that. We also have effect and log. Nice. So is small is, again, just string is the input. That's this s here. We take the length of it, which comes from there. One thing you can use to like help yourself out is pursuit.peerscript.org. So you can like search for length. There's a bunch of different lengths in here. And my guess is that this length may have worked. Not really sure if. Oh, yeah, it just returns a semi-ring, so yeah, that should be fine. I think this length would just work. But also it looks like this is not part of a standard library, so it's fine. Anyway. S, where are those? There it is. Mod 2 not equal 0. Okay, so, oh, it still is not happy about this. Yeah, I think that actually we should probably avoid this library then. Although I don't understand where these warnings are coming from necessarily. Functors. Maybe. I don't know. Kind of curious if we can use this version of length and then not worry about this. Let's find out. Kind of curious. So instead of strings, let's just do it like this. Let's do this. And then instead of this, we will get data full dub length. Okay. Okay, so it's not smart enough to do this, unfortunately. Right, I didn't actually save that, which I should have. Okay. Fine. Data string code points like so, and then we'll just open this up. So anyway, I was just curious if that would work, and it doesn't. So this was called strings. Those are only warnings, but I was just curious about it. Okay, cool. So anyway, we see a function application here. We see a less than 10, so that gives us this Boolean. Same thing here. We're just using the mod operator. I think there's also like div and div mod and rem and other things. I don't know if it's exactly the same as in Haskell, but there we go. And then there's this Appendive function. So here we're saying, give me a function from string to Boolean, and then a string and another string, and I'll give you a string. So we just check the predicate against s, and if it's true, this is the semi-group operator, which is just like append. It's plus plus or whatever language you're familiar with. Otherwise, give you s. Cool. And then, bam, you can just append if it's small or append if there. which we'll just I'll just finish the code because why not? But I'm not gonna type the whole thing. I mean, I guess I could. It's not that hard, but I'm gonna be lazy. Although I think copying and pasting from this book is, or any book in events is not really recommended. I think it treats things like tables, and so there's weird tabs and stuff in here. There you go. Okay, so one thing that you might ask is like, what's this $sign here? It's just like do the thing on the right before the thing on the left. It would be equivalent to write parentheses here. So I just want to show you that. Like that. Those two things are equivalent in this particular case. Hey, Jappy, what's going on? I prefer the $sign syntax typically. Okay, so anyway, let's run our first Spago project. Spago run, I think. There you go. Good to hear. Good to hear. Yeah, everything's just a boring function. Nothing fancy to see here. I guess we just, we just get used to looking at this syntax after a while because, this does look different than any of the C languages that you're familiar with, but in my opinion, the terseness of Peerscript and Haskell to solve problems like this is I don't know, I appreciate it, I guess, but it's underappreciated, I think, by non-Haskell programmers, I guess. Maybe just because it looks so unfamiliar. Anyway. Yeah, anyway, they weren't expecting us to understand this code, but I do, so I guess it was helpful to explain, maybe. I don't know. And then we ran it just to show you. I think up to this point, Charles has not shown us how to install Peerscript. I can't remember offhand. So anyway, I showed you how to do this with Spago, which is kind of the build tool of choice nowadays. And you can just install it with npm. It's Charles Scalfani. Let me find him. Charles Scal. Yeah, here we go. This is the author. Really nice person. We sent some emails back and forth when we were discussing working on the book, and he's really nice. So just check him out. He wrote a 1900-page book for people to learn functional programming. So, that takes a special kind of person. Okay, there's a beautiful lack of parentheses. I mean that in a good way, by the way. You're saying yeah, but no, you are not the target audience. You already have very familiar with this language, and like I'm not the target audience either. It's just that I would like to put this on my YouTube, so that's why we're going through the book. And I wonder if some of the later chapters are potentially useful. I'm not sure. Like there's some not these. Let's see here. Man, there's a lot in this book. Yeah, like maybe there's some stuff about that in here. I don't know. Maybe there's something interesting in here about monads or monad stacks. I don't know. I think there's also like some async effect stuff, which I haven't really done that much with. Like I know how to make the types happy, but like I've not played with fibers or cancelers or avars or buses. So some of this later stuff could be interesting. I don't see like the FFI. I've not done FFI stuff in Peerscript. That would be useful, clearly. And then apparently there's something called HTTP Pure, which is I guess a window into Node, so you can write backend in Peerscript, which I didn't know about. So anyway, I don't know. It could be interesting, but again, like I said, it's not for me. I can't believe no one's done the giveaway command yet. I figured out it's gonna have to explain myself. Somebody's gonna do it now, obviously. Okay. Yes, agreed. Because when you go into other languages, you miss the terseness of Haskell. Okay. Yep. So function from string to bool is just string to bool. Here's the Haskell code. It looks exactly the same. The only difference is length is given to you by prelude. And apparently there's a function called pred. So we gotta hide it. Yeah, for the books. Okay. Well, I've glossed over a lot of details, which will go later in this book. Hope you see how similar Peerscript and Haskell are. Yeah, I would agree with this. Like, if you learn Peerscript, it should be relatively easy to write Haskell. Yeah, you would have to actually console log in Elm, and you would have to like boot up a browser to see anything. But Elm is not designed to write like code like this. So okay, so functions as return values. If functions are values and functions return values, can functions return functions? Yes. JavaScript also supports functions as values. Yep, so this is just a function, which is a value. Function, which is a value. Or, yeah, it's a first class function. Okay. Oh, and it's returning a function itself. Okay. So here we have I keep pressing the wrong button. It takes me kind of a while to wake up. I'm also trying to touch type, even though I've only had this keyboard for like 6 days. And I don't even remember where those keys are. What does this thing do? Oh, right. If it's even, it does some to upper function. Yeah. Right. These come from data car. So actually, it may be smart enough to bring these ones. Yeah. Where's he getting them from? String common, I guess. So we can get that. And then we should also get this one. Ugh. Okay. There we go. So yeah, I'm using the LSP here to bring in this stuff. Obviously, I could just type it, but it is what it is. Okay, so now we have some upper lowercase functions, and we can log their results. I'm not gonna type this whole thing out, but if it's even, that will become uppercase, and then if it's odd, it'll be lowercase, which is like a goofy little function, but you know, that's how this works. Okay. I don't think that this is like completely like I don't think that this would be completely foreign to somebody, right? Like it's pretty readable if you've ever coded before. I think maybe the syntax is kind of strange, but like you probably know what a modulus is. It's just like you're replacing it with percent in some other language. You might be surprised by the shape of this if, maybe, because you don't know that that's the only way you can write an if. There's no else if. Something like that. I don't know. And then obviously some of the, maybe this notation is kind of strange. All right. Yeah, that's a fair point. Like, even when we were trying to do this ourselves, we needed to import a library as well. Well, it was pretty easy. Okay, higher order functions. Oh. A higher order function is a function that takes a function as a parameter and returns a function or both. Yeah, first order or higher order functions. Look back at the Peerscript code and see if you can find the higher order functions and the first order functions. Okay, Peerscript code. This is a first order function, and I guess this is a higher order function. Oh, but it has to be a function, I guess. So maybe neither of them is that. No, well, okay, I was wrong. I think this definition is a little wrong. Oh, no, it's just that I'm reading it like a doofus. The comma is very important here. Okay. String returns a string. And since it's the return type of upper lower, it means that upper lower is higher order function. We'll delve into type signatures later. Da, 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 da. Okay, composition. I think you can't use the dot composition in Peerscript, right? You have to use the greater, 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 or is it less than, less than, less than? I forget which one's the dot. I think it's the less than version. Building larger things from smaller components is seen in nature, engineering, manufacturing. Da, 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 da. Okay, so if we have a function from y to z, an f, a g from x to y, then f dot g of x is equal to f of g of x. It's kind of weird notation, but I guess you just have to understand that the precedence of this is higher than the application itself, I guess. I feel like this should be in parentheses, right? Anyway. So, and then f of g of x's type signature is if you give me an x. What is this z? Oh, this is the z return value. Okay. For all x in x, and I guess this capital X means the domain of x. Is that the right term? Oh, I guess we're gonna talk about it. Great. F is a function that maps elements from the domain Y to the codomain Z. Ooh, we're using codomain. Nice. Don't forget that y and z are sets. For example, y could be the set of real numbers, r, or the set of natural numbers, n. What mathematicians call domain and codomain, we programmers call input and output, respectively. What does maps mean in this context? It means that f takes an element of y, traditionally depicted as y, and produces an element of z, usually depicted by z. Wait, you can do... Oh, no, this is just the -1. Okay, never mind. I was like, this is a section, but it's not a section. The arrow syntax is very familiar. The arrow syntax is very similar to the arrow syntax we've seen used in Haskell and Peerscript when defining its functions. For example, int to int, cool. The domain or inputs is int, codomain or output is int. Okay, g is a function, domain x to codomain y. Notice that g's codomain is the same as f's domain. The output of g is the input of f. This is a critical requirement if we're going to glue these two functions together. Yep. Okay, so first portion states that f composed with g applied to x is equal to. I still think that this is not like the syntax I would be familiar with. Does anyone agree with that? Wouldn't we normally see f.g in parentheses and then x? Maybe just an added set of parentheses here and here. I don't know. I guess it's fine since it's being explained, but it's kind of strange to me. Okay. Anyway, and then applying, yep, compose operator, cool. The remainder of this line states that f composed with g maps elements from the domain x to the codomain z for all elements x that are in x. Yeah, so that's basically what I read. Functional composition works from right to left. Yeah, I usually say f after g. This is the term that I use typically. Okay, so let's attack the whole thing. I think we already kind of did. So if this is unfamiliar, I wouldn't worry too much about it. A lot of this stuff is like you can convert it essentially to Peerscript code. Like there's a for all, well, or Haskell. There's like a for all syntax that you can use as well. We wouldn't use it here because we're using ints. So here's some examples. We have a int to string function, and we have a string to array string. So we can obviously glue to string, or sorry, we can say to array after to string, for example. And there it is. So, okay, so this is the normal like dot composition in Haskell. And this is saying to array after to string. And if you pronounce this as after, it's much easier to remember that you do this one first. Like in Haskell, the dot is, I guess, less obvious, maybe, but you also have the dot in the notation, so I think it's fine. Yeah, and instead of using so like in here, I guess I don't know why I'm always comparing this to Haskell, but I guess it's just because that's what I feel familiar with. This operator is equivalent to dot, and this operator is equivalent to that in Haskell. But I think they read a little nicer in Peerscript, if I'm honest. It's more to type, but it's more obvious what's happening and which way like things are going. Okay. Cool. Ooh, fun pictures. Yeah, I think the composition looks a little nicer. Oh wait, you think it's which one is an abomination? I disagree. I think that this is pretty readable. I think the intent is more clear. And like the forward and backward composition looks the same, which is nice, I think. Well, that's fair. Okay, there we go. So we learned some stuff here. Cool. Point free notation. Um, we could write not. Oh, yeah. I guess that's a good point. This is a point free notated function because we don't take an input here. It's written that way here as well. I didn't even notice. I just like accepted it. So we'll talk about point free here. Yeah, I think I've seen those before, the Haskell version. Okay, so notice how our not large function has no formally defined parameters. That's because it's written in a form called point free. So there's a saying in our chat, which I haven't really hasn't been brought up in a while, but it's point free for the sake of point free. So we would write functions in point free notation just for fun, but you don't have to write them in point free. It's just sometimes it looks nicer when they're not point free, or sorry, sometimes it looks nicer when they are point free, and sometimes it's like unreadable nonsense. So anyway. So we could write not large in this style. So we actually explicitly take a number and then write like this. We could also write, for the sake of comparison, not large. This takes an int to Boolean. Like this. But I need is large apparently. I don't know what is large is supposed to be. Come on. Can't type. Where's is large? Do we even write is large? I don't see it anywhere. Okay, well, it's not defined, so it's fine. We'll just define it. So this needs to take an int to an int, it looks like. I don't know. N is greater than 1,000. That's pretty large, I guess. Oh, needs to be a Boolean. Okay, so anyway, you could write this way. So it's like, I'm just trying to point out how you would remove the num. So it's like you have this composition already, and you know that these are composed in this way. So you can rearrange this to say like not composed with, or sorry, not after is large applied to num. And so I just want to write it in that syntax. And then you can easily see like this n is kind of unnecessary. So you can just remove it because all you care about is the composition of these functions, because the composition of those functions gives you the thing you need. And you don't even need to name n, which is nice. Like that saves a lot of typing in some cases. Okay. Point free version reads like English. Yeah. Not after is large. So I chose this as opposed to that, which reads is large not. Yeah. So sometimes, again, it depends what you're doing, but sometimes the forward composition is just a little makes more sense. And like I like to read code in English as well. So yeah, it would is large nint exactly. um. Okay, so let's assume you wrote this function. Okay, I'll suppose that. Um, right. We have a compiler, which is kind of problematic. It's not problematic. It's okay. What does pad left do? It takes a string. Sorry, that's a character, and then it takes an int and a string and produces a string, apparently. Um, can I just put a hole here to make this happy? Uh, undefined. What do I put here? Error? Like this? How do I ignore some function in Peerscript? Is there a to do? Oh, I was already in pursuit. To do? Okay, so it's in debug. So we should be able to say to do, and it takes a string, it looks like. And then we should be able to get that. It's not in here. Fine. Okay. Do we need to include debug? Is that debuggest? Debuggest. Okay. I'm fine with this. Hey, what's going on, unavailable? How are you? How is your programming language exploration going? Come on. There you go. Okay. Nice. Good job. I'm glad you started. How's it going? Um, a wildly unsafe function. Yeah. Placeholder in pure script. I swear there's like something to do that. Undefined in Peerscript. Do. Nothing there. Peerscript's equivalent to error. Throw? Yeah, but that's an effect. That's not going to work. Yeah, this would work. Unsafe perform effect, I think. Okay, so we first need to remove that. Rerun our build real quick. And then delete this. Define this function. Where does throw come from? I just want to put this in place because, of course. Okay, it's just in a library called exceptions. I suppose it would have been easier just to write that function, but I guess this is useful for people who have never done like this kind of stuff, because you'll see some of the tools that I'm using to like find things. I don't know if that's useful. Okay, so now that we have that, we no. Okay, and then instead of this to-do function on 37, we now have an error not implemented yet. Okay, so there we go. So we could define this, but I'm not gonna like throw a bunch of weird Peerscript at you. Instead, I'll throw a different weird Peerscript at you to introduce this error. So like we can just like avoid evaluating this, but it makes the types happy. So we know it knows that the type of pad left is character int string, and like we could implement that in a pure way, but we're choosing to just say we're not going to implement this yet. We'll implement it later, and there's some tools that are there that allow you to do that. So that's what I'll say about that. And so now we can write this zero pad as this, and the question is it possible to write this as a point-free function? And I believe that it should be. I think that you can, well, you can remove this here, and you get that one for free, I think. And then in theory, I think you can just remove this too, but there may be something about currying that's necessary to make this compile. I can't remember. It doesn't look like it. I think it's just fine. We'll just double check. Yep. So yeah, you can just like remove these arguments because they're essentially pointless. You're just trying to fix this character to pad left with zeros. And I suppose this would be better if you called it zero pad left or something. Pad zero left. I don't know. Yep. So like again, there's the function that we're building, and then here are the things we're applying it to. So there you go. Yeah, and that's kind of what I did, is the cancel on the right thing. So it's like it's on the right, cancel it, and that's kind of what I was trying to show here. I didn't know that he was going to bring this up as well. So we cancel that one, and then boom, we're done. The technical term for this is eta reduction. term comes from lambda calculus. Yep. So it says one thing to keep in mind is that the order of parameters matters, which makes perfect sense, right? Like if you flip these things, then you have a problem. You can't really apply them that way. It wouldn't make sense. Okay, currying. Currying is a very powerful tool that is used all the time in Haskell and in Peerscript. So let's see what we're gonna learn about currying. What time is it, by the way? Okay, we'll go for a few more minutes, and then I want to talk about the giveaway stuff. So do you remember that one of the restrictions of FP languages is that all functions only take one parameter? This restriction comes from lambda calculus, which was created by mathematician Alonzo Church. But the name comes from Haskell Curry, who, like Church, set out to base logic and this way. Yeah. Okay, so in lambda calculus, functions can only take one parameter. They are written in the following notation. So this defines a function that takes x as an input and returns this thing on the right. I don't remember all of the terminology here. Like there's names for these things, but it's just a lambda function, I guess. So you can write this like this in Peerscript, which is just like an anonymous lambda. Yeah, and then the slash kind of looks like this, and hey, what are you doing? What are you doing? Stop moving my microphone. Okay, so don't forget that functions can return other functions. So this is saying given x, I'll give you a y that returns x plus y, and then you can write that in Peerscript like this, or and then you could apply it to something. For example, cool. Yeah, and then basically there's this binding phase where you start to bind your variables. So this thing will bind x to 3, so you could replace every instance of x with 3, and then basically just drop this, and then you get that. And then you can do the same thing where you bind to 5. Stop! What are you doing? Where we bind 5 to y, and then you get this. So can you still hear me if I'm this far away? I think you can, but I'll move this a little closer. And then you can just apply these functions, so you get that. So in these languages, okay, in lambda calculus, you can't write stuff like this, but basically this means the other function we showed before, /x2/y2 x plus y. And this is used frequently. So yeah, again, this is just kind of like sugar to this, and the compiler will do that for us. Cool. Yep, let's look at the named function add. The type signature is right associative, which implies the function is curried. All type signatures have implied parentheses that are right associative. So yeah, these are the same thing. This means that. There's add 3, which you can write this way, or you can just leave them off because, again, it's right associative. Cool. Seriously, why? Why are you so needy? Neat. Okay, so here's show 3, which is just showing 3 integers separated by parentheses. Again, right associative, so you can just drop all these parentheses. Here's an example where you can't drop the parentheses because this thing takes a function that converts it into a string. What's up, what? How you doing? We're learning about currying today. Well, actually, we're just talking about functions mainly. And then here's an example where these things are left associative, and so you can't drop the parentheses. So this G takes a function that takes a function to produce an integer and produces an integer. So yeah, this is pretty interesting. So the apply, if you were trying to figure out what the implied parentheses are, basically just start by taking the things on the right and putting in parentheses, and then find the next arrow and put that thing in parentheses. So yep, Cool. And this cat is so silly. Okay. Cool. Hi. Yeah, so this function is fully applied, and then we were talking about partial application before, where we kind of like partially apply pad left to 0 so that we can define a 0 pad. And partial application is like the coolest thing in here. Like I love partial application a lot. Hi Leila. Okay, simple example. I just want to finish this section and then we'll talk about the giveaway. So just give me a moment. So here's our pad function, which we're just filling. It takes, I guess this means, here's Boolean blindness at its fineness. It's, are you padding on the right or the left? Yep, because that's pad false. And then we take whatever character we're going to pad with. And then we take how much padding we're going to add, and then the string we're going to add it to. And then we can define all of these things by partial application. So we first define pad left, pad right by partially applying out the Boolean. And then we 0 pad or space pad by partially applying again. And then we partially apply yet again. So you can see like we're building up functions from other functions, and it's beautiful. And I promise you this goes like a really long way and is incredibly useful. All right, kitty, you gotta get down. I'm gonna have to stand up here in a second. Okay. So what are we doing here? So this is changing the order, and it kind of, I mean, you just have to change the way that these things work, but this looks much more awkward to me than the first one, for example. Okay, so it's worth spending some time planning the order of your parameters. The general rule for parametric ordering is to have the parameters that change the least to be the leftmost ones, and the ones that change the most to be the rightmost. Yep, that makes perfect sense. So pad, clearly you want to write pad left and pad right. Probably try it. Yu-Gi-Oh, how's it going? I feel like I haven't seen you in a little while, but how are you? I'm going to talk about that in just a second, and I will explain it. I'm just trying to finish this section. And actually, let me write a note. Hello? Oh, I'm just using the wrong character. Okay. Cool. We can pass a bunch of strings to .pad 20. Okay, cool. So we finished chapter 2. So there's that. Let's go here, and we'll write in our we don't really need to write anything. We'll just leave this alone. Okay, cool. So that's chapter 2. We talked about functions, and then now we're going to talk about the basics of Peerscript